Hello everyone, this is Arthur Morris and welcome to Solving Absolute Value Inequalities. Okay, with absolute value inequalities, after you isolate the absolute value to one side of the inequality, if you have an absolute value that's less than something else, then that represents an AND compound inequality. If you have the absolute value of something that is greater than whatever else, that represents an OR compound inequality. So you would want to isolate the absolute value to one side of the inequality. Check to see if it's a valid inequality. Remember, the result of taking the absolute value will be greater than or equal to 0. So if I have the absolute value of something that's less than 0 or less than a negative number, then it's not valid because anything I take the absolute value of will be 0 or greater than 0. So after you check to see if it's a valid inequality, then you create case 1, which is the regular case, and case 2. Now since we are multiplying by a negative, case 2, we flip the inequality symbol and change the sign on the right-hand side, or multiply by a negative on the right-hand side. After that, we would solve each inequality and write the solution in interval notation. Okay, so let's look at a few examples. Okay, this example here, we have the absolute value of x is less than or equal to 3. Well, that's valid. It's less than a positive number, so that can be a true statement. It's already isolated, so case 1, just drop off the absolute value symbol and write your inequality. There's nothing to solve here. We have x is less than or equal to 3. Case 2, flip and change. So we flip the inequality symbol and we change the sign or multiply by negative on the right-hand side. So it becomes x is greater than or equal to negative 3. Now, since we started off with x is less than or equal to, that represents an AND inequality. So remember, your AND inequalities would be where the two inequalities overlap. So we have x is less than or equal to 3, and at the same time, x is greater than or equal to negative 3. So we have the or equal to on each one of those. So let's look at a sketch of this graph. It means we'll have a bracket at 3 and negative 3. And if it's less than 3 but greater than negative 3, that means my solutions or the intersection is in between the two numbers. So my final answer would be bracket negative 3 to 3 bracket in interval notation. Okay, let's look at another example. All right, we have the absolute value of x minus 2 is less than 7. Again, the absolute value is already isolated to one side. So my next key here is to look to see what the absolute value is. Is it less than or greater than? Look at the inequality of it. Since the absolute value of this is less than, that tells me that this is an AND inequality. Less than gives you an AND inequality. So case 1. Case 1, you leave it just like it is, except you drop off the absolute value symbols, and then you solve. So x minus 2 is less than 7. Add 2, add 2. X is less than 9. Case 2, flip and change. So we leave the x minus 2 like it is, change to greater than negative 7. So again, we solve this by adding 2, adding 2. X is greater than negative 5. So we have x is less than 9 and x is greater than negative 5 at the same time. So it's in between those two numbers, greater than negative 5 but less than positive 9. Now this time we don't have the or equal to, so remember, we would use parentheses because we don't have the or equal to bar. That's how my graph would look. So I can easily write the interval notation, reading from left to right, parentheses, -5, comma, stops at +9, parentheses, in interval notation. So again, the absolute value of something less than is an and inequality. The absolute value of something that is greater than is an or inequality. All right, so we have the absolute value of 5x minus 5, and then outside of the absolute value, symbols plus 15 is less than 10. Now, before you make your determination of the and the or, you need to first isolate the absolute value. So now let's subtract 15, subtract 15. So we have the absolute value of 5x minus 5 is less than -5. Now let's think here. Whatever we take the absolute value of would result in 0 or a positive number. We can't take the absolute value of anything and get something that's a negative number or anything less than 0. So when this is telling me that I can take the absolute value of whatever this turns out to be, and I get a result that's less than -5, well, there's no way I can do that, because everything I take the absolute value of gives me a result of 0 or something greater than 0. So therefore, my answer is no solution, because I cannot take the absolute value of a number and get something less than 0. Okay. All right. The absolute value of x plus 7 is greater than or equal to 12. So that's valid. I see that this is a greater than inequality, so that tells me that this is an or inequality. Case 1, you leave it the same. X plus 7 is greater than or equal to 12, and you solve. Subtract 7, subtract 7. X is greater than or equal to 5. Case 2, that's our flip and change case. So we leave the x plus 7 like it is. We flip the inequality symbol and we change the sign. Or multiply by -1 is really what we're doing. All right, subtract 7, subtract 7. We get x is less than or equal to -19. So let's do a sketch, a quick sketch of that graph. So let's say we have 0 here. Let's say we have 5 here. And let's say all the way out here we have -19. So if x is greater than or equal to 5, that will be a bracket on 5 to the right, all the way out to infinity. If it's less than or equal to -19, it will be a bracket on -19 all the way out to -infinity. Now remember, the or inequalities is where you merge the two graphs into one particular graph, one solution. So both of these graphs will be a part of both of these lines will be a part of my solution. So my interval notation from left to right, all the way out here from -infinity to -19. And remember, there's always parentheses on your infinity symbols. Now, since I have this gap, we union that gap with this symbol here, and then pick back up at +5, all the way out to +infinity. And again, there will be parentheses on the infinity symbols. Okay, so let's look at one more problem. The absolute value of 3/4 x minus 1 is greater than -2. Well, the absolute value symbol is isolated, so we need to check to see if this is a valid inequality. What can I take the absolute value of that will be greater than a negative number? Well, if you think about it, whatever I take the absolute value of is greater than a negative number, because if I take the absolute value of a number, I either get 0 or a positive number. So everything that I take the absolute value of is greater than -2. So it does not matter what I plug in for x. My answer will be all real numbers. Again, remember your definition of the absolute value. When you take the absolute value of something, you either get 0 or a positive number. So in this case, when it tells me to take the absolute value of something, it's going to be greater than -2, then everything that I take the absolute value of will be greater than -2. So it's all real numbers. Okay, hope you found this video to be helpful. Thank you.